Okay, so if we've got things in polar form, so when two complex numbers are in polar form, their product and quotient can actually be found quite easily. So if we've got one complex number written like this and another one written like this, so let's just use the example we just did. So Z1 is root 2 cis 3 pi on 4. Let's say Z1 is root 2 cis 3 pi on 4. And Z2 is another one, which we will choose 2 cis negative pi on 6. 2 cis negative pi on 6. Then Z1 times Z2, these two multiplied together, is actually just your moduluses multiplied together, your moduli is multiplied. There it is, R1, R2. And then cis, you just add the angles. So literally, for this question, Z1, Z2 is just 2 root 2 cis, and then add these two together. So 3 pi on 4, which I won't simplify, just so I can demonstrate it to you. There you go. 3 pi on 4 plus, and then minus pi on 6. And if you simplify it, that's what? 18, take away 4 is 14 over 24. Simplifies 14 over 24, 7 over 12. Easy. So when you're in polar form, you can just multiply your modulus and add the arguments. Any questions?
No.
And obviously, what do you do when you divide? You get to take a wild guess. R1 over R2 cis theta 1 minus theta 2. So when you divide, you subtract your angles, and obviously you divide your moduli. Okay, nice and simple. Brad, give me the answer for the first one. 2 cis 33 times 3 cis 27. 6
6
cis.
cis.
What do you do to the angles when they're multiplied?
Add them.
Add them. 33 plus 27, 60 degrees. Next one, root 6 cis pi on 3 divided by root 2 cis pi on 6. Root 6 on root 2. Caleb, what's the answer? We're dividing this time.
I'm not sure.
2 root 3.
Modulize. What do you do to the modulus when you're dividing in polar form?
Oh, subtract. Would it be?
No, subtract was angles.
Division.
Yeah. Division, so that should be root 3. And then cis. Now you subtract.
Minus.
Yeah. So 60 take away 30. Pi on 3 minus pi on 6, which equals to root 3 is pi on 3. Pi on 6. 6 take away 3 is 3. You're on 18 minus 6, yeah. Do you guys realize the problem with part C? What's different in part C? Can I write this as cis straight away? So remember, cis theta is cos theta plus I sine theta. The fact that it's minus, it's actually not in polar form. Has to be a plus sign for it to be a polar form. So what you can do is you've got to go back to understanding what cos and sine can do with different angles. In fact, note cos is an even function. Cos is an even function. That means if I cos a negative 3 theta, it is actually the same as cosing positive 3 theta. So it's the same. Sine, however, sine is an odd function. That means sine of negative 3 theta is actually the same as negative sine of 3 theta. I know you haven't learned this, but that's just how that works, right? You're in extension 2, you're always going to learn a little bit more than you know up to now, I guess. But then once you learn it, you're meant to keep a note of it, write it in your book, keep it in your theory books, and then hopefully, as you study this, you get to remember these. So how can I convert this? Well, now cos 3 theta minus I sine 3 theta can actually be written as cos negative 3 theta plus I sine negative 3 theta. So that's the trick. To make that back into a cis, you make the angles both negative 3 theta. Now, that's allowed because I just said they're the same. That's allowed because we're bringing the negative back in, as you can see. We're bringing the negative back in, which means it becomes positive I sine and a negative 3 theta. So you can see it there. Sine negative 3 theta becomes negative sine 3 theta. Negative sine 3 theta. And then that can be written as cis negative 3 theta. If we do it again, cos 2 theta minus I sine 2 theta is the same as cos negative 2 theta plus I sine negative 2 theta, which is the same as cis negative 2 theta. And then, can somebody give me the final answer for when I multiply them?
Sorry, it's minus 5 theta.
The minus 5 theta? Yeah. So the idea is you're not technically expanding using binomial expansions and whatever. The nice thing about polar form is all you do is just the numbers on the outside, you'll just multiply them, and the angles on the inside, you can just add them. Makes life a little bit easier, especially when we do the next bit, you'll see. Just keep that in mind. Now, you don't need to know all of that. What you need to know is, okay, for negatives, that's not in cis theta form. So what I can do is actually make the angles both negatives, and then all of a sudden I can write them as cos theta plus I sine theta again. I can write it in polar form again, not polar form. Very important. Okay. Any questions? Okay. Don't need to worry about that. No. Yeah. We will do these. I just want to see. I'd rather not do it today, and I'd rather do it next week. Yep, that's all next week. That's fine. Yeah, we could do that as one question, but you know what? We'll leave all of that as revision for next week. All right. Last bit for today. De Moraes theorem. De Moraes theorem, usually pronounced as sometimes pronounced de Mau's theorem. So it's a French mathematician. A lot of silent letters, let's say, but you'll probably hear me say de Moraes. So de Moraes. Moray, I guess. Moray. All right. De Moraes theorem. Actually, a very, very powerful theorem. He says this: when n is an integer, and if I've got something in polar form, cos theta plus I sine theta to any power, actually, it can be expanded quickly to this. So what's happened? What's happened from this power to this? What has happened? What did he just say you're allowed to do? He said cos theta plus I sine theta to the power of n equals, now look at it.
You times the angle by the power.
That's so good, because think about something for a second. Think about, hold on. So think about this question, right? 3 plus 2i squared. Is that easy to expand, Julia?
Ye.
What if I all of a sudden made it into power of 7? Still easy to expand? No, but we now know that we can convert this to polar form. So let's just say we did, right? And for hypothetical reasons, it became this. It's not, but just accept it. It became root 3, we'll just make it 3. 3 cis, and then pi on 2. Right? And then that's still going to be to the power of what? 7. But now, because of this theorem that we've got, look how much easier it is to expand. 3 to the power of 7, which I didn't write there just yet, but 3 to the 7, and then cis, you just multiply the angles. How easy was that? Something that was really annoying actually can be done very quickly. Any questions? So, his theorem, very, very useful, right? You have to have it in polar form. Again, just since we were here with the question previously, please keep in mind if it's a minus, that's not in polar form, right? So just keep that in mind. Anyway, it has to be in polar form. And then it's got a power. I can actually just bring that power in by multiplying the angles. Nice, easy. We can't do the proofs until we do induction, which is in year 12. Yeah, we can do these questions. I think we're done for today. Yep, that's next week. Good stuff. Let's do these bits, and then we're done. All right. Question 1A. Julia, you can be the first one. Why not? We've got cos theta plus I sine theta to the 5. What can you do straight away?
Cos 5 theta plus I sine 5
Do you want
theta.
to leave them as causes, or do you want to put them as cis? Up to you.
Okay, cis.
Cis, okay. Cis 5 theta times cis 3 theta over cis what?
6 theta.
Yes, 6 theta. Then, what did you learn before De Moraes theorem? When you multiply polar form, what can you do to the angles?
You add them.
And then what happens when you divide them?
You subtract them.
Do you feel like you're even doing extension 2?
No.
And like, I don't know, we're just multiplying things and adding and subtracting. It's all new, don't get me wrong, but then isn't permutations and combinations new? What isn't like calculus new? I mean, everything's new. Like, whatever, so easy. Anyways, B. All right, Rav, you get a question like this in your exam. What do you do, Rav?
Multiply it by the.
Look, you've got power of 5 in this expansion. Are you even going to be able to expand that to the power of 5? You've got to use like binomial expansions. No good.
Wouldn't it be just root 3 minus I to the power of 6 on
Because
3 minus 1?
because have you multiplied the
Yeah.
conjugate? Is that what you're trying to say?
Yeah.
All right, let's do that step then. So Rav's saying let's multiply by the conjugate, which is
Because
fine. Yep, so hold on. Then that becomes root 3 minus I. You didn't have to do this for those who didn't think like that. You didn't have to. I guess the bottom becomes 3
minus 1.
plus 1,
Oh,
right?
yeah.
Because minus I squared,
Yeah.
so 4. Okay. But you're still stuck. How do I expand this? Annoying. You don't want to expand this. So what you're going to do is convert this to polar form,
Yeah. Totally.
right? So can you tell me the R value when you convert this to polar form? What does R equal to? What is the modulus equal to?
Can someone help me out here?
Sure. Someone help him out? 2. Can you tell us how you got that?
Root 3 squared plus minus 1 squared.
Yeah, pretty much. A squared plus B squared, and then you square root it. Cis, and then again, inverse tan for theta, inverse tan B on A, don't forget that. 1 on root 3, which is 30 degrees, but then where is this located? Located somewhere down here, so negative pi on 3. Is that correct? Pi on 6? Just double check that, Rav, in case I did the inverse tan bit wrong. Is it right, Rav?
I think so.
So you did inverse tan, 1 on root 3, and it gave you 30 degrees?
Yeah, it should.
Yep, and then negative. All right, cool. All right, Rav, what about now then? What can you do? Well, the modulus has to still be to the power of 6. That's not an angle. But then cis, what? Six times this, negative pi on
4.
and then 2 to the power of 6 is
2
30.
to the power of 4 is minus pi.
Say it again.
Isn't it just 2 to the power of 4 is negative 180?
Yeah.
I mean, negative pi.
Hold on. Take just do one step over. One more time. What's 2 to the 6?
2 to the 6 is 64.
64. What's 64 divided by 4? 16. You don't need to leave it as 2 to the power of 4. 16 cis negative pi. Let's leave it like that for now. Done? Let's do C. C. All right. C. The idea with C was you're meant to use my solution. Otherwise, you would have to do it all again. So C. How do I convert 1 plus cos theta plus I sine theta in polar form? It's the one that we did here. So you're not meant to do it all again. There. 1 plus cos theta plus I sine theta becomes this. 2 cos theta on 2 cis theta on 2. Right? That's what I was trying to go for. So for C, it'll look like this. All right, let's write it down. 1 plus cos theta plus. Otherwise, if this was in an exam, yes, you'll have to do it yourself. But I've never, ever, ever seen it in an exam because it just takes, there's too many things. So what they will do is maybe step 1, write this in modard form, and then step 2, maybe you can do this. But still, hasn't been asked. Cos theta minus I sine theta. Okay. Like I said, the first one, I'll give you the answer for because we've already done it. So that was 2 cos theta on 2 and then cis theta on 2 to the power of 5 over. Somebody tell me the answer to this when it's a minus. What does it become? Cis what?
Oh, cos minus theta and then plus.
Plus I sine minus theta, which becomes cis negative theta. Right?
Mm-hmm.
Good job. And then power of 5, 2 to the 5, cos to the 5 theta on 2, cis 5 times theta on 2. Be careful, that's cos to the 5. Maybe I'll do that. You guys don't get that mixed up. Over cis negative 3 theta. And then what do you do here when you divide cis? You would subtract the angle. So 5 theta on 2 plus 3 theta, which is 6, 11. 11 theta on 2 is 2 to the 5 cos to the 5 theta on 2. Like I said, I've never seen it, but it's good. Good algebra to do. All to learn. All right, I'm gonna leave D. I'll leave D as a one little homework, but just so I know you can execute it. What's the square root of negative 3 equal to? What does the square? Yep.
Square root of 3i?
Yeah, root 3i. But if you're wondering where the i's are, it's right there. I've heard that before. Sam, we've never had any i's, so we didn't know what to do, but square root of negative 3 is root 3i. So just keep that in mind. Okay. We'll leave that as homework. All right, and I think we are done.